So over here, I've been given the graph of some function f of x, and my overarching question that I'd like to answer is, what is the limit of f of x as x approaches 2? Well, most of you are probably going to be telling me right away that, Trevor, I think it's pretty obvious that the limit as x approaches 2 does not exist, because you're rightfully going to tell me from the previous videos that you've studied and from your previous studies of limits that the right-hand limit over here is not approaching the same value as the left-hand limit over here, so therefore the limit does not exist. And I'd be telling you, yes, you are correct in your logical thinking like that. The limit does not exist. But in this video, I'd like to do something a little bit different. I'd like to see, is there another solution that we can maybe come up with for this limit as x approaches 2 of f of x? So let's go ahead and take a look at it. So first up, let's take a look at the right-hand limit. I want to look at what is the limit as x approaches 2 of f of x. So what is the limit as x approaches 2? Again, we're doing it from the right-hand side. What is the right-hand limit as x approaches 2 of this function f of x? So we're looking at values really close to 2, but on the positive side, so 2.1, 2.01, 2.0001, etc., etc., etc. And I'm noticing the kind of general trend that's happening is it keeps shooting upward. It's not like we're actually converging on a certain point as we get really close to 2. In fact, as we get really close to 2, it's getting bigger and bigger and bigger and bigger, as indicated by this arrow. This not the yellow part, but the blue part right there is indicated by that arrow. It's just getting larger and larger and larger and larger and larger. So the limit as x approaches 2, from the positive side, the right-hand limit as x approaches 2 is actually infinity, because it keeps going up and up and up and up and up and up and up. So what about the left-hand limit? What about the limit as x approaches 2 from the left of f of x? What is that going to come out to be? Well, again, we're looking at as you get really close to 2 from the negative side, so 1.9, 1.99, 1.99999. And we notice that, again, it's getting very large. It's continuing to grow, but it's continuing to grow downwards. So it's getting really big in a negative direction. So a number that's really big in a negative direction is negative infinity. So as we can tell, the left-hand limit does not equal the right-hand limit. We can say that the left-hand limit does, I guess that's yellow. So the left-hand limit does not equal, I'll do that in white, does not equal the right-hand limit, and so therefore the limit as a whole still does not exist. But what I want to focus on really is this key spot right here. These are what we like to call infinite limits. Infinite. I'm going to see if I can fit it on the screen. I can barely do it. Barely, not really. Infinite limits. And basically what infinite limits are is there are limits as x approaches, as when x approaches a certain value a, the limit output is either infinity or negative infinity. And we have some applications of these that I'll get to 2 videos from now after we go over some other concepts of infinite limits. But for now, what I want to do is, these are called infinite limits. We'll need to use these concepts in a little bit to prove some certain pre-calc stuff that we can now do with calculus. But I want to do a couple example problems of trying to find infinite limits if you're given a limit. So I want to go over here, and I want to solve these problems. So we're asked to find the following limits. We're asked to find the limit as x approaches 2 from the positive side of 3x minus 1 over x minus 2. We're asked to find the right-hand limit. We're asked to find the left-hand limit, and then we're asked to make a conclusion on the limit as a whole. So let's go ahead and do that. Let's take a look at the right-hand limit first. So I'm going to go ahead and do direct substitution. All these across, I'm just going to do I'll do it in orange up at the top. Quick direct substitution. What am I going to get if I directly substitute into this? So I'm going to get, well, 3 times 2 is 6. 6 minus 1 is 5. So I'm going to get 5 in the numerator. And 2 minus 2, I'm going to get 0 in the denominator. So right away, we already can tell that this isn't possible, that we're not going to get a value that exists for this limit. But I want to hit pause, and let's analyze this a little bit deeper. And I guess I'll leave that up there. Analyze this a little bit deeper and see what kind of we can come up with. So if we take a look at this a little bit deeper, we're looking at 2 from the positive side. So we're looking at numbers a little bit bigger than 2. So we're just going to make a general conclusion here. We're just going to say that x is equal to, I think we can agree that 2.01 is a little bit bigger than 2. just like a smidgen bigger than 2. So we're going to go ahead and do that. Let's go ahead and do direct substitution with this value and see, let's see what we get when we plug in this value into the limit. So I'm going to get 3 times 2.01, and for those of you that really don't want me to do that, let me pull out the handy-dandy calculator app. And so 2.01 times 3, that's going to be 6.03 minus 1. That's 5.03. And then we're going to divide that by 2.01 minus 2. And we got 503. We got a really big number. And so, well, let's think about this as a whole. Is if x is any number that's a little bit bigger than 2, like this, what are you going to get out at the bottom? You're going to get at the bottom, you're going to get this number, you're going to get just some number. You're going to get a number value out here at the top. And on the bottom, you're also going to get a number value, but you're going to get a small number. You're going to get a small number. I should note that it's a positive small number. You're going to get a small positive number. So let's think about this. A number divided by a really small number is the same thing. This is the same thing as a number times a positive big number. So a number divided by a really small number is the same thing as the reciprocal. So the reciprocal of a really small number is going to be a really big number. And so we can make the conclusion that any number times a really big number, I think a good example of a big number is infinity. Any number times infinity is just going to be infinity. So the limit as x approaches 2 from the right-hand side is going to be infinity. So let's try that same logic over here. Let's pick a number. What's a number a little less than 2? How about 1.99? So if we plug that in, what would we get? And I closed my calculator for some reason because I thought that was smart. So what are we going to get in this case? We're going to get 1.99 times 3, and then we're going to subtract 1 from it. And it's going to be divided by 1.99 minus 2. And we notice before we divide, we notice that we get a really small, we get a small, but instead of a small positive, we're getting a small negative number. And it's giving us a very large negative number. So I think we can make that same conclusion. We're going to get a number, some number value, over a negative small number. A negative small number. And so just like the logic before, that's going to be the same thing as a number times a negative big number. A negative, you can barely see that, times a negative big number. And a big negative number I associate to be negative infinity. So this limit as a whole is therefore going to be negative infinity. And so then if we make a conclusion about this, about the limit as x approaches 2 as a whole, we can just say that, all right, the left-hand limit is not equal to, well, let me do this. Let me do this a little bit over so I can write my answer. The left-hand limit does not equal, I'm not satisfied with that. The left-hand limit does not equal the right-hand limit, and so therefore the limit does not exist. I really want to put more emphasis on A and B than I did on C. I thought C was just a little bit a good review for what we've been doing recently, so we can keep all that content fresh in our head for the AP exam. But mainly I wanted to just talk about how we can find limits that equal infinity or negative infinity, and just talk about that. So yeah, I'll see you guys in the next video.